Okay, so here's our problem. We're on the ocean, and we've got an island between us in our big ship and the enemy ship, and we want to lob a shell over the island and hit the ship. And we know we're 2,500 meters away from the island, and the other ship is 610 meters on the other side of the island. And if we launch at a 75-degree angle at a speed of 250 meters per second, the question is, are we going to hit that ship? Secondly, we want to know how close to the top of the mountain are we going to be. So, that's our question. Now, as with any projectile motion problem, you have to treat x and y independently, and it has to follow the kinematics equations. So, we're going to treat them independently, and we're going to use specifically the second kinematics equation. So, think the physics. In order to know how far it goes, we need to know the velocity that it's traveling horizontally and the time that it's in the air. So, our horizontal velocity is our initial times the cosine. That gives us 65. And we need the time up. Okay? And you'll notice here that it's always going to be the initial velocity in the y direction. So again, we're looking right here. Initial velocity in the y direction divided by g. So initial velocity in the y direction involves sine. And so the time up is 24 seconds. Times the 2 gives us the time in the air, so we're looking at roughly 48 seconds. So that gives us, if we use 65 and 48 seconds, multiply those, and we get roughly 3,100 meters. Okay, we'll go with that for a while. So, initially they were 2,500 plus the 610. That gives you roughly 3,110. So you're within 10 meters based on the numbers that we used. Again, focus on the physics though. Don't get all wrapped up in the numbers. So you're at least going to get them real wet, and certainly afraid of your awesome physics calculation skills. Indeed. So the next part of the question asks us, how close to the peak of the mountain do we get? So, in order to know that, we need to know the time it takes to reach that mountain. So we're going to use our horizontal. And since we've already calculated delta, well, we know delta x, and we've calculated velocity in the x direction, that's the initial times the cosine of 75, we've got time, 2,500 meters, 65 meters per second, takes us roughly 38.5 seconds. So we take that time then, at 38.5 seconds there, and we're going to plug it in to our equation, and when we do that, do all the math magic, that number, it gives us 1886, It was a good year in our country. I'll leave you to research why. So it's roughly 86 meters above the peak. Now, one thing I want to point out, and this is really critical because it was interesting to me. I went back and I redid the problem, and I used 9.81. You might have noticed if you go back, say we go back to here, notice, okay, I used -10. Well, I'm not focused on the math. If you go back and you use 9.8 and you use, the time actually comes out to be 38.6 seconds and all that. So if you do all of those things, you get different numbers. Okay, don't worry about that. Worry about whether or not you've done the physics. The physics is what we care about. This is physics class, not math class. So unlike your math class where you have to have 13 decimal places correct, otherwise you are a lousy person. Not so in here. Okay, we need to know the physics. So focus on the physics. Thank you very much. Oh, guess what time it is? It's yippee yahoo.